Welcome back, everybody. This is our video solution to problem 7 from the fall 2021 Math 302 final here at Cal State Fullerton. This question, we are going to try to identify which of the following four statements is not a group axiom. So we're going to select one and explain our reasoning. Well, we'll explain our reasoning on all four. Let's see, this first one, the composition of any three elements, A, B, and C, satisfies A composed with B composed C is the same as the composition of A and B with C. And this is one of the group axioms. This is the associativity axiom. So this is definitely not the correct answer to the question because you have to notice, right, it's saying which is not a group axiom. So this one is a group axiom. How about B? There exists a unique element that acts as an identity under composition. All right, so well, this is an interesting thing because in one sense, this is not actually a group axiom. Because you can assume just that there is an element that acts as the identity, and you don't have to assume that it's unique. But very often we actually do write down our axioms and just put in that it's a unique element, right? We did that just to expedite it. If you don't believe it, you might say, well, imagine I had two of them, call them E and F, and then we can prove that E and F have to be the same thing. Because if I multiply two identities, well, E and F, then, well, E is an identity. So multiplying it by F, you just still get F. On the other hand, if I notice that F is an identity and I multiply by E, then I get E. So E and F actually have to be the same thing. So this would be a reasonable point for you to go, I mean, is it really a group axiom? No, it doesn't have to be. But we can take it as one. It doesn't give us anything different. All right, I'm going to skip C for a second, which should tell you actually which one of these is the correct answer. So D, the composition of any two elements in the set is again an element of the set. And this is actually just the fact, right, that this composition is a binary operation. And we do assume in a group that you have a binary operation. So D is definitely not the correct answer. So that leaves us with C. The composition of any two elements does not depend on the order they are composed. So I'm going to do this in red so we know it's not true. If I write this down, this is what it's translating to. The composition of any two elements, right? So I have, say, an A and a B, doesn't depend on the order they're composed. So A composed B would equal B composed A. This does hold, but only in abelian groups. Now, it could happen in non-abelian groups, but it won't happen all of the time. And if it does, that's an extra condition, and that means you have an abelian group. So an example of a group where this doesn't hold is the symmetric group on three letters, where if I compose the transpositions 1, 2, and 1, 3, in this exact order, I would get 1, 3, 2. But if I reverse the order, then I'm going to get 1, 2, 3. So the order does matter typically in a group. All right, so there we go. There's our answer. Option C. All right, we will see you next time, everybody.